Homework time, yes, happy homework time is here yet again. Yes, let's start by jotting our name down at the top of the paper. Don't want to forget to do that. Here is the dealio. I will write my name and you write yours. And let's take a moment, do things right. Write today's date. I'll write today. You write the actual date, where and when you are in this world. For number one, don't you just love this geometry stuff? It's fun. Pictures. I love it. On each object, trace at least one pair of lines that appear to be parallel. And I'm only going to do this once to you, but look at the spelling. Par, all, L, E-L. Par, all, L. But we say parallel, of course, but help you to remember that. So let's look. Lines that are parallel are equidistant. They're the same distance apart at all points along the lines, whatever direction they happen to be going. And if you were to extend those lines to infinity, they would never meet. So on our happy little t-shirt here, so what I'm going to do is I'm going to change colors so that you can see my lines better. And I'm going to use the line function to make my lines a little bit better. I said I'm going to use the, okay, there we go. All right, so that line clearly is parallel to this one, the two sides of the shirt. Now, the only other straight lines we have are here, because it says at least one, so we can do more than one, are here. This is kind of short, but indeed, this one here is parallel to the top of the sleeve. See that now? And of course on the other side as well, we're just going to do a bunch of them. We don't have to do all of them on all these pictures. In fact, we definitely will not want to. But see, those are parallel as well. With the bottom of the shirt, the neck seems curved. I'm not really sure about the shoulders. They basically look straight, but I'm going to leave well enough alone. The obvious ones on this sign are the edges of the sign, right? So this line is parallel to this line. They are the same distance apart at all points, and as well for the other ones. But here on the arrows, I could trace this line here, or close enough to it, and then any of the 1, 2, 3 other lines of the arrows would be parallel as well. I'm going to pick this one because those are parallel there. On the guitar, not much going on with parallel, huh? Well, there is at the same time. The strings are obviously all parallel, so I can just draw 2 lines for the strings. And then both the frets along the fretboard here going across the fretboard, as well as the guitar pickups down here, are parallel as well, but I don't want to muddy things up by tracing too much on that one. So here, on the flower pot, we have this top line is parallel to this line, which is also parallel to the base line there, but I'll go with these. It's also useful to note what is not parallel. For example, both the upper and lower parts of this pot are trapezoids, so they both have one set of parallel lines. You notice the outer sides here, those are not parallel to each other. And looking at the flower itself, nothing parallel going on there. Shopping cart, or as they call it down south, boogie. So on your boogie, we have the grid, so we have the lines going vertically and the lines horizontally, but I'm going to go ahead and trace the base of the cart with the foot of the whole carriage here. Those are parallel, right? And just to be nice, I don't want them to feel left out, the vertical lines, this line is also parallel to that one, right? Or I could do any of those. The obvious one on the roller coaster are any of these vertical lines going up and down, right? Say that one and this one, we'll pick 2 that are right next to each other. Those are parallel. And then any of the lines going horizontally as well. But notice also the diagonal lines. Let's do one of those, that's fun. So say that one and that one. Although all of the horizontal lines, vertical lines, and diagonal lines are parallel to each other. All right. I think this woman's hair is, all right, never mind. Let's go on. And number 2 is asking us, how do we know if two lines are parallel? If I remember rightly, back on lesson 3 homework, we had to answer this, but the word was perpendicular. So two lines are parallel when? So let's start our response here. Two lines, although the 2 is kind of unnecessary, just simply lines are parallel, because we deal with them primarily in pairs here, but you could have any number of lines within a set of lines that can be parallel. Right? Two lines are parallel if, and here's how I like to explain it and to use a math word, if all points on each line are equidistant. And perhaps as you could, I'm sure there's the mathematically minded who could take issue with my phrasing in all points, but we understand that all points opposite one another on each line are equidistant. We can add here as well, also, if extended, the two lines would never, what would they never do? They would never get married. They wouldn't even meet. They would never, our math word is intersect. All right. So that's parallel. So now in the square and triangular grids below, we're going to use the given segments in each grid to draw a segment that is parallel using a straight edge. I'm going to use my little line tool here. And so when I look at this one, the base of the line, the far end of the line, is 1 square over. So wherever I start from, I'm going to end 1 square over. So I'll do it here so it looks good. It's in a similar place. You see what I'm saying? So like this would be straight up and down. That's not parallel. And if I went over 2, that's also not parallel. But if I go the distance of 1 square over, which is how that one is, now they're parallel. And now for this jobber, see, he goes down 2 squares. So if I'm going to draw a parallel line here, I could start anywhere, but I'm going to start here at the edge. I just have to make sure I go down 2 squares. See that? If I just did 1, not parallel. If I did more than 1, still not parallel, but 2 squares is the formula. Beautiful. And now over here, they made this first one pretty easy. It's just going straight up and down. And I don't have to draw it, here, like 1 away or 2 away. I could draw it over here. It doesn't matter. It's still parallel. It doesn't matter how far they are, as long as points are equidistant. And now when you look at this one, it goes down from the vertex, the left vertex of this, well, when we look at the diamond here, it goes down 1, 2, 3 vertices. So if I start a line, say here, I'm going to go down 1, 2, 3 vertices. Okay, so look at that. How's that? Ah, there we go. That's it. See? Like that's a no good. Yeah. That's a no good, right? Hey, that's a nice. There we go. Beautiful. You like that? All right. It's pretty fun stuff, I told you. All right, let's go on and look at the next one. And number 4, we have some detailed instructions. We are to determine which of the following figures have sides that are parallel by using a straight edge and the right angle template that you created. Circle the letter of the shapes that have at least one pair of parallel sides. Mark each pair of parallel sides with arrows, as they did, and then identify the parallel sides with a statement modeled after one in 4a. So here let's look at 4a, they said, okay, AC and BD, these 2 line segments are parallel, so they marked them with the arrows, and they also then wrote line segment AC, and this symbol means is parallel to line segment BD, and of course they also circled letter A, so we know that we have parallel lines. Now, because we're not really doing this mathematically, we honestly don't really need to use a straight edge and a right angle template to be sure that these lines are parallel. We are able to look at these figures, and you'll have questions like this on tests, and just determine which ones appear to be parallel. So look at this trapezoid, right? And it's a trapezoid, so I kind of gave it away. That's going to have one pair of parallel sides. Where are they? Well, this one here. And this one here. These guys are parallel, right? And so what's the name of this guy? His name is HI. Line segment HI. And when I write the parallel symbol, when it's typed, it is supposed to look like this. But when I write it, I like to make it a little tall so that there's no confusion that it's not a 1 or 11 or anything else going on, or eyes. So I make it kind of tall. It is parallel to line segment JK, and that's what makes it a trapezoid, right? All right, now when we look here, whoa, almost forgot, we got to circle B. Right, there we go. When we look here at C, gosh, could you even draw? Any triangle that has a pair of parallel sides? Think about it. Imagine all the triangles you've known in your long, long, lonely life. Did any of them? No, you can't. You cannot draw a triangle that has a pair of parallel sides. Go ahead and try. Can't do it. So this one, notice, by the way, if we double check our instructions, we're to do nothing with C because there are no parallel sides. We don't have to circle, write, or mark anything up. And now look at D. That's just there to make sure if you did something with D, then it would indicate to your teacher, okay, this kid has no idea of what parallel means. So we don't even really have sides here, do we? So how can we talk about parallel sides? Silly little oval. All right, let's look at the rest of these wonderful little shapes. Boy, isn't this geometry homework fun? Well, look, here in E, they give us another triangle. I mean, these sides aren't parallel. None of that. Leave you alone, E. Okay, now in F, we have, what do we call this shape? It's a rectangle. It might be tilted up, but we don't call it anything like a diamond. That's not really a geometric shape in math. It is a rectangle. And we have our choice now. You remember back in A, the one they did for us, they didn't mark all the parallel sides. Although the directions were a little fuzzy on this, it appears we are only to locate one set of parallel sides. So I'm going to go with OP and NM, although you could do ON and PM. And I'll circle letter F and then write my little statement here that line segment OP is parallel to, so that means line segment NM. Boom, there we go. And so we can have a little fun here. 6 sides, right? Okay. Hexagon. So we could do the long sides, but hey, I like to be a little different. So I'm going to do this little TS, who is parallel. Yes, over here, PQ. You see how those are parallel? And of course, we could have done SR is parallel to UP, and of course TU with RQ. So we'll circle G. It's got 3 pairs, although we just had to identify one. So line segment ST is parallel to line segment QP. Beautiful. Well, let's look at H. So lots going on here. We've seen this arrow before, actually, in our lesson on perpendicular lines. So the 2 points of the arrows are not parallel to any other lines, huh? You see? Now the obvious one would be TZ and XY, right? Those are obviously parallel. But again, I like to be a little different. So I noticed that UT here, this short little line, is parallel to ZY. So is WX is parallel to ZY. But I'm going to mark UT and zy, because those are parallel, and I like to do things a little differently. I'll circle letter H, and I'm going to say that line segment UT is parallel to line segment ZY. Beautiful. We've got some more to do. Let's roll on. All right, and again, you notice these questions closely parallel our questions from the lesson, the homework on perpendicular lines. Ha, little math joke there. Ha, moving on. True or false? All shapes with the right angle have sides that are parallel. Explain your thinking. Oh, this is a tricky question. Now let's think. It says all shapes, and that's important because let's draw some shapes here before we get to answering. I could draw a right triangle. Oh, right there. Boom. And that has no parallel sides, okay? So the right triangle doesn't. Now, here's how you test it, though, with quadrilaterals. Go ahead and draw a right angle. And then try to draw two more sides so that they are not parallel to the opposite side. Well, so if I didn't want it to be parallel to this lower line, the top line, well, I could draw it down. And in order to make the foreside not parallel to the left-hand side there, I could just extend this out so it goes like that. Now look, that's a four-sided figure with a right angle. It's quadrilateral, has a right angle, and it has no parallel sides. So this would not be true of that, and then obviously of a quadrilateral either. And once you get past four sides, it becomes surprisingly even more easy to draw it so you do not have parallel sides. So if we just start with the right angle and then we want to make five sides, I mean, I could even do this: 3, 4, 5, and unless I'm really missing something, that's, I mean, it's a highly irregular pentagon, but it is a five-sided closed polygon with a right angle, and it does not have parallel sides. So this is patently false. If we went on with more sides, they would become harder to draw, but they would not require parallel sides. So you have to answer the question, which here is false, and obviously they want us to explain. Okay. So we could say right triangles cannot have parallel sides. No triangle will, right? It's not going to be a triangle. Because, and like, let me explain that. If you just drew two parallel lines, right? Make that a triangle. Not happening, right? You can't draw one line that closes the figure, all right? So, oh my goodness, cannot have. That's what you get when you're talking and writing at the same time. See, so that's why your teacher's always telling you to hush. Right triangles cannot have parallel sides. Okay. Now, however, polygons with, and by polygons I'm talking about figures that are closed figures, closed plane figures, so any shape. So polygons with a right angle and more than three sides, so more sides than a triangle, can have parallel sides, but, and we could say, but don't have to, or but not necessarily. I'll explain it the way a fourth grader might, but but don't have to. They need not. Okay, and your illustrations here, by the way, we didn't just do those for fun, although it was, help to explain. So explain now here in 6 why line segment AB and line segment CD are parallel, but line segment EF and line segment GH are not. Okay, so why is that? Okay, so line AB, look at it. What makes these parallel? They are line segment AB from line CD, and then look at EF and GH. You can see that these are not. So why is that so? So why are A, B, and CD parallel? So A, B, and CD are parallel because why? Yeah. Okay. We can use that if we extended them. Definition of pair lines. Okay. If we extended them, they would never intersect. And I mean never. You could spend the rest of your life extending those lines and it would be a wasted life because they would not intersect. Now, however, look, if we extended EF, we can imagine that there, and we extended GH. In fact, let me go ahead and do that. I'm going to change color here again so we can kind of set it off. So I'm going to take point F here and do my darndest to extend it straight out, right? How's that? And I'm going to take point H here and extend this line segment out. And what do they do? That's right. And we'll change back. They intersect. So we can explain this as well. We can say these are EF and GH. So line segment EF and line segment GH will intersect if we extend them. So they are, yes, parallel. Excellent. You thought we were done, but we're not. We got one more. There's one more. Let's wrap it up now. Yeah, moving on home. All right, number 7. Ha! I have it easy because we have to draw a line using a straight edge and then use the right angle template and straight edge to construct a line parallel to the first line you drew. Hey, I'm going to cheese out on you here. I'm going to draw myself a nice big fat line. All right, so there's the line you draw with your straight edge. And then you're going to use your right angle template and straight edge to construct a line parallel to the first line you drew. So if you lay your straight edge underneath the first line, the question for you is, well, then how do you use that right angle template to construct the line parallel to the first line you drew? Well, basically, if you use the right angle template to line up one end of the line, right, and so you get that equidistant from the upper line point, and then this one you again use your right angle template. You can mark a place on it, or you could actually, if your straight edge is a ruler, you could use that again. And so then you're going to make a second line that these are the same distance apart. Does that make sense? All right. Hey, no, that's it. So when you're done drawing your two little lines there, your homework time is complete. Nice job. I will see you again next time. It is once again homework time.